Okay, time to get started. So welcome to Math 216. We've got some introductory stuff to talk through. There's a bunch of logistical kinds of things mostly, but anyway, it's got to get done. First, quick comment. If you are a math major or minor, hypothetically, you want to come talk to me as soon as possible. This might not be the right course for you, depending on which of those and other things. Okay, so the class website, I think y'all have already got. I sent an email with that information and a bunch of other stuff, of course. By the way, if you have not been getting my emails, or if you have not received any emails from me, send me an email so I'll know who you are, and then I can take all the old emails I've sent and forward them to you. I want everyone to be up to date on everything. There's a lot to see on the web page. Your assignment, if you haven't already done that, done the following, is to read everything on the main page. So let's go take a look. Here's my sort of launching page. You find Math 216 right there for the spring semester. Be careful with that. Here it is. So there's a lot of stuff here. My information. By the way, notice my office hours are right here in this room, pretty much. Unless there's nobody asking me questions, in which case I go back to my actual office right over there. But right before class starts, pretty much. So 2:30 to 3, Monday, Wednesday, Friday. So I figure y'all are all coming here anyway. And I'm usually happy to go past 3, as long as I don't have something else that's, demanding my time, like if I've got to go print something out before class starts or who knows what. That's my office hours. Y'all have discussion sections that are led by teaching assistants. Here are the 6 TAs for the class. They all have office hours. They list their office hours individually on their web pages. For example, here's one of our TAs, Stephen, and his office hours are not listed yet. Okay, so he needs to update this with his office. So he'll have his office hours on there soon. Okay. Other things, various links. We're going to go through a lot of these in the next few minutes here. Syllabus, lecture schedule, etc. And then other things that you might find useful. All of my old midterm exams with solutions. That's pretty handy, right? Bunch of study material there. I encourage y'all to all look at. Various other things. This, I think, is an important thing to point out. Recommendations concerning schedule. This is how I think you should be spending your time in preparing for this course. The thing I'll point to specifically is look how much it is. Right? There's a lot of things to be doing. It's not just come to class and then make sure you get the homework in on time. Right? There's a lot of things that you should be doing in terms of making sure that you're keeping up as much as possible and therefore coming to class able to get as much out of it as you possibly can. So, please take a look at that. Notice that what I have written here, is for the flipped portion of the course. We also have the second half of the course, what I call the traditional, do that in air quotes, traditional portion of the course. And the structure is a little bit different, so how you spend your time will be a little bit different. So this recommendations are correspondingly a little different. Okay. There's a lot of stuff to read here. A new thing that I've added for this semester, advice on how to do well in this course. I've always had various little bits of such advice sprinkled throughout the web pages here and there. But here I've put together, I don't want to say all of them, but the big highlights for how to do well in this course. Various resources and how to take advantage of them. Big FYI on what are the expectations, right? What am I assuming that you'll get out of this course? What will I be looking for on exams? That kind of thing. So there's a lot of important things to note. So make sure to read through all this stuff. These used to be pretty much this introductory spiel. It just got to where it was taking too long. I didn't have enough time to get everything said. So these things are all now written down. So make sure to read all this. It's all really important. Likewise with the expectations. And then lastly, there's another new section on asking questions in class. Short version, I encourage you to ask questions, but I recognize that there are a lot of reasons not to, depending on the circumstance. So here I go through various such considerations. The punchline I'll leave you with, make sure to read all this, of course, is if you're not sure if you should ask the question, you're welcome to go ahead and ask anyway, and just be prepared for the possibility that I might say, hey, that's a good question. Let's talk about that in office hours. Right? So in other words, if it's something that I think the rest of the class probably won't get a lot out of, and that's more of an individual me and you kind of thing, then or something else with the same conclusion, then I'll just suggest we talk about it later. Okay, no problem if that happens, right? No offense, no harm. Okay, all right. So this whole main page is part of your first day reading assignment. Now, I want to note also, though, there are some links here up at the top of the page. These 5 links, I want to walk through and point to what's here. Again, I'm not going to read through all of it, but I want you to read all 5 of these links. So, policies. How do I view the Duke Community Standard? What's the deal with attendance? Can I use calculators? How do I deal with short-term illness, etc.? Right, that's all here. General comments. This section is a bunch of random miscellany, really, all of which I think is something you should know. It's important in some way or another, but doesn't really fit in necessarily very well elsewhere. But there's a lot of it. Again, make sure to read through all this stuff. I know it's a lot. Okay. Let's see here. Here's a bunch of stuff about graded items. How to interpret exam questions. What do exam grades mean? And if you don't get a good grade, what can you do about it going forward? Stuff like that. Again, a lot of stuff. Make sure to read all of that. Proofs in Math 216. We're going to be doing some proofs. Now, we're not going to be doing anywhere near as much proofs, anywhere near as much abstraction and rigor as Math 221 does. Math 221 is a sort of a math major on-ramp course. Math 216 is not. Math majors need to be much more exposed, much more prepared to writing proofs and understanding abstractions and understanding rigor. But linear algebra is unavoidably wrapped up in a little bit of proof and a little bit of rigor, and we're not going to do a tremendous amount, but we have to do some. So a lot of you, most of you probably, have never had a proof class or a class that's even particularly proofy, but Math 216 will be a little bit. So anyway, what is a proof, and what's not a proof? A lot of discussion here on this page. So make sure to read this one. I'm going to go ahead and point, since we have plenty of time today, but this website linked at the very bottom, I think is really fun. It's a list of invalid proof techniques that people sometimes try to use, and it's just for fun. But this is my favorite one: proof by intimidation. Right? You just declare it to be trivial. And then you dare your audience to doubt the triviality because it makes them look bad, right? So I just think that's hilarious. Proof by vigorous hand waving, also pretty funny, right? Also not valid, but anyway, there's some funny stuff in here. Okay. Right. So let's see here. Where are we? So 5 links. The last one. You'll all be interested in this one. The grading system for the course. This course used to use a grading system that was pretty common in 100 and 200 level courses in our department for many, many years. And it was a very good grading system for several reasons that I won't go into because we're not using it anymore. But that old grading system did have a big flaw in that it was not very transparent. And that led to a lot of student sort of like discomfort. And it was all, by not being transparent, students ultimately did not understand where the grades came from. So I've done with this new grading system, new as of a year ago, as I recall, completely done an about face on that. This new grading system is extremely understandable and it's extremely transparent. I'm going to walk you through it right here. I think you'll agree that when we're done is very simple. So graded items, for example, on exams, you will get a letter grade, like A-, for example. Now, how that's done, on your exam, you'll have a score, and then I'll send out a curve that converts scores into letter grades. Letter grades will then be translated into a number on the 4-point scale by way of this, this usual association here. So A-, 3.7, etc. Okay. Midterm exams, your homework average will get a letter grade. Your quiz average will get a letter grade. Your attendance will get a letter grade. So with the midterms and the final and the homework and the quizzes and the attendance, that's all the graded items for the course, and these are the weights that we will use to then do a weighted average, straight up, simple weighted average on the 4-point scale of, therefore, these numbers. Right. So when you do that weighted average, by the way, if you're not clear what a weighted average is, no problem. Come talk to me. I'll be happy to explain. It's a real simple idea. That weighted average will give you a course score, overall course score that will fall into one of these bins. So, for example, let's suppose that your grade is your average, your weighted average, let's say 3.581, let's just say. Well, that falls into this bin, and you get an A- for the course. So, I think it's a very simple system, extremely transparent, right? And I think it's important that we have that kind of transparency and simplicity. Anyway, there it is. By the way, I'll point out while we're here, this allows you to do various kinds of speculations. So, in particular, there's a couple of examples here. Suppose you have A's on the first 2 midterms, and you're pretty sure you're going to get at least a B+ on the 3rd midterm, and at least a B on the other graded items. And with those grades assumed, you're like, oh my gosh, what do I have to get on the final in order to get what grade in the course? Arithmetic, right? Algebra 1 you can solve. For example, noticing that those average to a 3.5, right? 3.5, anything higher than a 3.5 is an A- in the course, and there you go. So it's just arithmetic, and you can play all sorts of speculative games of, given what grades I already have and what grades I'm feeling pretty good about, where do I have to be with my other grades? Okay. I'll also point out, a lot of students, after the 2nd midterm, will already be able to conclude that they have passed the course. And that's reassuring, right? Going up here, notice that in order to pass the course, I know that's not most of y'all's goal, just to pass, right? But nevertheless, all it takes is a 0.6, right? And you can get a 0.6 with these 35%. With those 35%, if you have at least a 2.0 average, multiply arithmetic, gives you a 0.6. So anyway, certain nice features, I think. Okay, so let me hit the pause button here real quick. Does anybody have any questions so far? Everybody happy? Okay. All right. Okay. All right, so let's go back to here. Yeah. So all the main page, all the links at the top. That's your first day reading assignment. Make sure to read all of that carefully. Make sure to understand all of those discussions. And I'll say here, please interpret literally. There are a lot of classes, especially high school math classes, where there's a lot of big talk about, we're gonna very demanding, creative applications of problems, and then that never really necessarily transpires, right? In this class, it really will. Y'all know the reputation. Math 216 is a very challenging course, anyway, That's why. So please interpret all this as written. And also, by the way, while you're on the website, click around, see what other stuff there is there. You don't have to read everything that's on every link from every one of these pages, but at least know what's where. Okay. All right. Okay, so let's talk a little bit about logistics. The syllabus. Let's go back to the course web page. Right near the top of the course web page, right here, syllabus. This shows everything that we're going to be, it shows all of the book sections that we're going to cover, and it shows which exercises from the back of those sections are going to be assigned. So when we get around to assigning, for example, section 1.2, these are the assigned questions from that section. Okay, now while we're here, I'll also point out there's this thing called AHP. That's just short for additional homework problems. So when we assign section 1.2, that will include additional homework problems 10 and 11. Let me show you where to find those. Over here, also on the web page. There we go. Right there, additional homework problems. And here you are. Scroll along. Some of them are kind of long. Here we go, number 10 and number 11. Okay. All right. The purpose of these additional homework problems is I felt at various points that the book's exercises I felt like gaps in what they really should have to test the ideas that I think are most important. So I just wrote some additional questions. Okay. So, that's the syllabus. The lecture schedule, let's talk about that. Again, linked from the class webpage. Again, right near the top. Here it is, lecture schedule. So this will indicate roughly what we're doing in every class period for the semester. So, for example, on Wednesday, January 22nd, we are doing lecture 6. I'll get in a minute to how to find out exactly what lecture 6 is. But that will allow us to have completed section 1.4. And then those exercises will be due Friday, January 31st. You'll notice, while we're here, that I've done some shading in this rightmost column. Dark shading, light shading, dark shading, light shading. That's just a grouping, visual sort of grouping tool. These three lines here, you'll notice all have the same due date of Jan 17, which is here. The shading is just to again, make it a little bit easier to see. Okay, so these sections, namely just section 1.1, due on Friday, January 17, right there. Okay, so a lot of information there. Notice that the exams are listed here on the lecture schedule. So exam 1, there it is, February 5th. What material will be fair game for the exam? Well, color coding. So the exam 1 is listed in light blue. Here's the light blue days, and so you can see these sections all the way through here are all fair game for exam 1. Okay, so likewise, yellow for exam 2. Green for exam 3. Everything's fair game for the final exam. By the way, there will be content on these days, here and here, they happen too late for me to be able to put them onto a midterm exam, so they're not on a midterm exam, but they are fair game. Everything from the course, all fair game for the final exam. Okay, and so all of this will get filled in as we go along. I've filled in all of the flipped portion, because with the flipped portion, it's already set exactly which sections will finish by what time. When we get into the traditional portion, I hope to get through these indicated pages on a given day, but sometimes I go a little slower, sometimes I go a little faster. We're never exactly on schedule, so that I'll fill in at the appropriate time. Okay, questions? How are we doing? Yes?
When do we change from a flips?
Yeah. So that's going to be right up here. So the last fully flipped day is February 28th. And then the transition day will be Monday, March 2nd. What's actually going to happen there is there'll be about half of that class will be flipped, and the other half will be not flipped. And I'll give a detailed email around that time to let people know what to do about that. Yeah. Anybody else? Okay. Right. So let's note spring break and other holidays are on the calendar here. Yeah. Okay. So let's see here. Back to here. Yeah. The recording schedule, right. So that's the next thing we need to talk about. Back to the web page, right here under the lecture schedule, recording schedule. So this shows for any given lecture number, how do you prepare and what are we going to cover? So we talked previously about lecture 6. There's lecture 6. Lecture 6, you'll notice I have these, this is a spreadsheet and I have those cells all merged. The box here for lecture 6, you'll notice, covers these 3 lines. Don't pay any attention to these lines over here. These lines over here are just to demark book sections from other book sections. The lectures are done differently. So lecture 6, you'll watch this pre-lecture video on special matrices, this pre-lecture video, start of section 1.5 on cofactors, and this pre-lecture video, the next part of 1.5 on area and volume. Okay. So these are the topics being covered. Starts on page 40 of my lecture notes, ends on page 49 of my lecture notes. So the lecture notes are on the Sakai site, and of course y'all have copies of the book, and the pre-lecture videos are on the YouTube channel. Okay, so the recording schedule gives you a lot of important information. So you want to make sure to have this file pretty easily accessible, either download and print, or download and put it into a very convenient folder on your computer or tablet or whatever. Okay. All right. Questions about this before we go on? Pretty clear, I think. Everybody happy? Yeah. Okay. Right. Okay. So we've already talked about the AHPs. Cool. Oh, and we've already talked about the grading system. All right, so moving along. We're making good time here. Okay, right. So lecture recordings. I put the disclaimer here, might be made. Sometimes I have a technical difficulty. An HDMI cable dies. That's happened to me before. Bulbs on the projectors could burn out. That's happened to me before as well. Sometimes my computer has some sort of something went wrong. For some reason it doesn't work the way it's supposed to. At that point, we'll have to have a chalk talk. Of course, I can't record a chalk talk. Gosh, I may have forgotten to mention, we are currently recording right now. I guess I should have told you that at the start of the lecture. I don't think anybody's said anything incriminating, so hopefully no problem. Anyway, if you ask a question at this point, your voice might be picked up by the microphone, and you may be permanently enshrined on my YouTube channel. So anyway, keep that in mind. By the way, I think the microphone is not very sensitive. It'll pick up, look how much closer I am to the mic, right? I think if you ask a question in a reasonable volume, I don't think you're going to be recorded, but still. Okay, so hopefully you've already been to my YouTube channel and seen how it works, but just in case you haven't, here on the website, lecture recordings, pre-lecture recordings, etc. Go to the YouTube channel right there. And here it is. Everything's organized by playlists. So go to the playlist thing, tab, what have you. The pre-lectures this is the oldest playlist because I posted them first. And so you can click right there on view full playlist, and here they are. All the pre-lectures. Okay. Y'all have already watched these first 3. I hope. Okay. And then now that's for the flipped portion of the course. Now, when we get to the traditional portion of the course, there will be no more pre-lectures. There are no pre-lectures beyond that point. And I'll have another playlist. It'll be about right here. You can see the one I just made for my Math 212 class. And this is where I will put, my Math 212 recordings. There will be an analogous Math 216 for this term playlist. And it'll have all the videos that we'll start recording in mid-February or whenever that is, when we switch to the traditional portion. Yeah. Okay. Okay. So I want to encourage y'all to make a lot of use of the recordings. This includes both the pre-lectures and the live lectures that we'll start doing in the traditional portion halfway through the course, week 8, whenever that is. So it's a great way to study throughout the course. If there's a topic that you're not quite understanding, go back and listen to that part of the recording. You don't have to listen to the whole recording. Just find that particular part. Listen to that part again. It can be really helpful. Make good use of pausing when you're watching the recordings. I'm presenting the material at sort of full pace, right? But I'm also sort of assuming as I'm going through and presenting those ideas that if you are a little bit confused by something, if you just need a little time to kind of sort those ideas out in your mind, hit the pause button. Think about it. Take the time to kind of okay, so but this means that, but that means that. Wait, what was this thing again? And how does this relate to that? And what did that tell me about this? Take however much time you need to make those connections, and then once you have it straightened out in your mind, hit play, off you go. Okay. Before exams, topics that have been plaguing you, right, throughout the previous weeks. Before exams, if you want to just hit those again, go to the recordings. Right? Watch those recordings again. While you're doing the homework, it may be that a homework exercise is heavily involved with something that I did in an example in either a pre-lecture or a live lecture. So it's a great way to get help on the homework. So lots of good uses. I hope you'll take advantage. Specifically, here's an idea that came from a student from a couple of years ago. Annotate your lecture notes with timestamps. So let me show you what I mean by that. So you got to have a copy of the lecture notes in order to be able to do that. So let's suppose that you're having trouble with this business right here. And, as you're watching this pre-lecture, I hope y'all remember this part of the pre-lecture. As you're watching this, golly, I'm really not clear. I didn't understand that point, right? About, equivalent statements, for example. Then just in your copy of the notes, be they hard copy, printed out, what have you, or electronic that you're looking at on a screen, just go over here and write down what time it is. So let's see here. Right now it's 3:48. Here, let me say that differently. Write down what time in the recording it is, right? Or what time in the live, if you're looking at a live recording, just write down the time, 3:48, right? And then at some later time, in your copy of the lecture notes, you come back, oh yeah, wait a second, what was the deal? I didn't understand that. What was the deal there? What did Bray say about that? Then you've got a little note right here that tells you where to fast forward to in the recording. And you can go right to it. Right? So anyway, it's a quick little hack. I encourage you to do that. Okay. All right. Okay, pause again for questions. Anybody have any other questions? Everybody's happy. Okay. All right. So let's talk about attendance. Recall that attendance does count for your grade a little bit. I've already forgotten what the number is. Let's shoot. Let's go up and find it. Grading system. Weights. Attendance is 3% of your grade. It's not a lot, but it's definitely enough to make a difference. And so coming to class, really good thing. By the way, while we're here, let me point out that attendance scores tend to be really high. I hope that's not surprising, right? I mean, it's really easy to have great attendance. You just show up. right? So no problem having a really high attendance score, but that means that everybody else is going to have a high attendance score. That means that there's a high expectation, right? So it is not the case. Please don't misinterpret. It is not the case that 80% attendance will be a B. That is not true. The expectation is much higher. You should pretty much be here every day, right? And exactly how that is going to work will be determined at the end of the semester. Anyway, make sure to come. So it's only 3% of your grade, but that 3% can make a big difference. You look at the size of the bins, right? Sort of a 0.3 kind of, if you will, width in each bin, and so 3%. The difference between a 4.0 and a 1.0, 3%, it can make a pretty significant difference in your course grade. So make sure to come to class is the punchline there. The way attendance will work is in classes, in lectures, is when we get to the traditional portion of the course, I'll write down something called an attendance code. It'll be on the board right over there. I'll move that screen up about a foot so that there'll be space to make that visible. It'll be like a 3-digit number or something. And then on Sakai, during class, there will be a quiz that will be visible. And it'll only be visible during classroom hours. So you got to come to class, be physically present here during classroom hours. The answer to the quiz question is the number that's written on the board. So if you're here, you see the number, you enter it, you get your attendance point, nothing to it. If you're not here, you can't see the attendance code. Okay, so that's the idea. It's a little bit of a hack. It saves me from having to call names, which, again, logistically, I couldn't possibly do it. Okay, how are we doing on attendance? Anybody have any questions about that? Yes?
So if let's say theoretically everyone shows up to every lecture?
Yeah. Then if everyone shows up to every lecture, I'll give everyone an A. Okay. And very happily. Okay. Yeah. Absolutely. Yeah. Anybody else? It's a good question. It's a great question, by the way. Thank you for that. Yeah. Oh, let me also mention about attendance. Discussion section also counts. So the TAs will be taking attendance in discussion section. By the way, discussion sections do start this week. We're not deferring for the first week. So tomorrow or Friday, whichever discussion section you signed up for, discussion does meet. Also, let me comment. What I'm calling here attendance doesn't start until the traditional portion of the course. For the flipped portion, I don't take attendance exactly. The net effect is achieved by that being when the quizzes are. So what your reward for attending class for the first part of the class is that you get a shot at answering the quiz question. Okay. Any questions? Is everybody on board? Everybody happy? Okay. Yeah. Okay, so let's see here. Last item I have on this list, but I do have a couple other things, I'm a big believer in study groups. It's one of the things I talk about elsewhere on the web pages, so y'all will read sometime soon. I think there's a lot of good to be had from working in study groups. So I hope everyone will, formally or otherwise, make yourself a part of a study group. It's a almost free way to get a nice resource, right? If you don't know anyone in the class, or if you don't know anyone that you think you'd work well with for whatever reason, I maintain, this is ultra 90s, right? But nevertheless, a study group email list, right? It's very, very low tech. Just send me an email and I add you to the list, and then I make sure that the people on the list, and only the people on the list, will have contact information for everyone else on the list. So it's as much as possible confidential way to find people, like-minded people who are looking for study partners. Okay. Now I emphasize all I do is sort of maintain the list. Y'all have to organize yourselves. I'm not going to pair people up, group people up, set time. None of that. That's all. Y'all deal with that on your own. Okay. Okay. So if you're interested, drop me an email. Any questions about that? Anybody good? Okay. All right, so a couple other things I want to talk about. This next one is from the administration. They want us to talk about emergency procedures. They've sent me this. They even call it a script. I'm not going to sit here and read it as a script. So what I'm going to do is I'm just going to go through and talk about they make some good points. I'm just going to kind of talk about the points as we go through. So stuff happens, right? And so first thing I will point out is if some emergency situation comes up and I'm not aware, right? So if y'all's phones are all blowing up with, emergency, right? And I'm just blissfully going off and talking about matrix exponentials or whatever, right? Please stop me, right? Raise your hand, yell, get my attention in whatever way you can, and make sure that I am aware that we have a situation, because I obviously I need to know. Okay. I think it's unlikely that we will be the source of a problem, right? But hypothetically, I don't know what it would be, but if you see someone walking by, we have such small windows, but if you see someone walking by out there with a large gun, right, then call it in, for crying out loud, right? You all have the Live Safe app, I hope, on your phones, right? Don't worry about bothering the cops, right? So, hassle them, right? So, and then likewise also make me aware. So call 911 if you don't have Live Safe. Use Live Safe if you do. And again, let me know. So then, what to do in various scenarios. If there's a weather situation. So a tornado, for example. I actually think we're in a pretty good place, tornado-wise. Right? Now, y'all are free to do whatever you want. But I suggest staying in this room. There's no windows to speak of, right? There's those little teeny tiny little windows there. This is pretty much an internal room, except for that one door. I'll talk about that in a minute. And I suggest we stay here. But again, y'all do whatever you want. What if we have a fire or something? Conveniently, we can get out of the building very quickly. Y'all know where the front door of the building is. It's just right through there. This is also an exit. I don't know which is better for a fire. The nice thing about that front door exit is once you exit there, you are now fully away from the building. That's not true with this door. That door is, I think, very useful, though, in the case of the, shudder to think, gun situation. So in terms of the best escape route, I nominate this door right here. Let me draw a quick picture of why. A lot of people think that the physics building is shaped like this, that being the front entrance. That's not really a very accurate picture. The physics building actually looks a little bit more like this. And we are currently located right in, there's this lecture hall that we're in, and that's me. Right? And here's me if there's a shooter. Right? So I'm going right out that door. And here's the beautiful thing about it. Now, in that direction we have the road and, the chapel and the Bryan Center, a lot of population, people walking around and stuff. Over here, this part of campus is like obscure parking lots that you're not sure how to get to, and the back ends of buildings that you don't know anyone who works there, and it's weird and confusing. And I just feel like if there's a shooter, that's not where they're going to go, right? So I think this is probably again, don't hold me to it, right? But I think this is a very safe area. Right? Obviously, if there's a shooter on campus, we don't want to run to the Bryan Center, right? So this is the opposite of running to the Bryan Center. So anyway, for your consideration, now I emphasize y'all are free to do whatever you want, right? It's your lives, and you protect yourselves the way you want to. But again, that's what I'm doing. Okay. Any questions about that? Everybody on board? Everybody happy? We've done our duty and talked about the unthinkable here. Okay. All righty. Let's see here. So the last things I want to talk about are the, let's see, where is it? Forgive me, I can't remember. In the earlier lecture, I know I did this, but did I talk about Wolfram Alpha in this? No. Okay. So I hope everybody is aware of Wolfram Alpha. I'm not going to comment on whether you should or should not you be using Wolfram Alpha. Of course, any work that you turn in this course has to be your own work. Right? So you can't type something into Wolfram Alpha, look at the printout, and copy it. That's obviously cheating. Okay. That's not why I'm showing you Wolfram Alpha. I want to give you a quick demo, though, of what Wolfram Alpha is capable of, and I'll tell you why in just a second. So let's just type in integral of x times the sine of x squared. Right now, there's no fancy syntax or code or anything like that. I'm just typing it in the most naive way I can think of, and hit return, and notice that it interprets correctly, and then it shows you how to do the integral. So that's pretty neato. But why am I showing you this? What does that have to do with us? Let's go back to talking about the goals of the course. Right? A lot of math courses are what I'll call algorithmic. If you see this kind of question, here's what you do. Right? Wolfram Alpha can do that. Right? So if what, in any situation, if what you bring mathematically to the situation is that you can crank out algorithms, right, then you are just a slow and unreliable alternative to Wolfram Alpha. You see what I'm saying? I mean, so that's not a good thing to bring to the table. That's not going to make a company want to hire you, right? Because they have free access to Wolfram Alpha as well, and the $5 a month or whatever it is to get the step-by-step solutions, way less than the salary you're asking for, right? So what is it that makes you useful in a situation? What makes you mathematically useful in a situation, company you want to work for, lab you want to be a part of, whatever? And it's the ability to understand things. Wolfram Alpha doesn't understand squat. All it can do is execute algorithms amazingly well, right? But nevertheless, it's just executing algorithms. So if you're looking at a problem, a new kind of a problem, where no one in your group knows the answer, no one in the group knows even how to get started on it. It's a real world scenario about, an oil tanker or something, and friction, and you haven't seen a problem like that before, right? What's going to make you mathematically valuable is the ability to take a new situation like that, take existing ideas that you have a deep understanding of structurally, right? See how the structure of those ideas apply to the new problem at hand, adapt as appropriate, right? And then be able to solve the new problem. Wolfram Alpha can't begin to do that, right? So that kind of stuff, getting a deep understanding of ideas, being able to take that understanding and apply it to real world scenarios, that's what we're going to focus on, because that's what's going to make you useful. So anyway, I think that's a cool point, and I like to be able to point that out. Now, in about a minute here, we're going to start the quiz. Let's see here. Before we get to that, let me very quickly come over here to the quiz section here and comment. So when we're doing the quizzes, exam conditions are in effect. So the quizzes are a graded item. I want to mention, though, for this first week, so for today and Friday, and for Monday and possibly Wednesday, depending on when drop ad ends, with the whole wait list thing, these quizzes will not count to your quiz average. So the first 3 or maybe 4, depending, of these quizzes are get started kind of freebies. Okay, so nevertheless, I want us all to take this quiz question seriously. This is a dry run. Let's make sure that you see the level of difficulty of the questions, and that you understand the mechanics of how to actually enter your answers, and et cetera. And then let's see, where are we? Here we go. So I'm going to put the quiz question up in just a moment. The question has an answer that's an integer. You'll enter that answer on Sakai. So go ahead and pull up your Sakai now. And here it is. Notice n could be any value between 10 and 20, so there are 11 candidates, 11 candidate values of n, and the question is how many of those 11 values of n have a certain property related to dominoes and checkerboards and stuff. You have 3 minutes left. You have about a minute and a half left. Don't forget you are going to need, once you decide what your answer is, you are going to have to actually enter that answer on the Sakai quiz, and then you have to click submit, and then it takes you to another page. You're going to have to click submit again. So at about 30 seconds remaining, you need to be entering your answer. Got about 1 minute left.
I have the answer. I just realized I'm not on the Sakai list for some reason.
Oh, we're going to have to figure that out. Wait,
Yeah.
Stick around for a minute after
Okay.
class is over. Yeah.
Do you want me to write my answer down on a piece of paper?
No, this doesn't count for your grades. It doesn't
Okay.
matter. Yeah. Just come talk to me right after class. Okay, you got about 30 seconds left. If y'all could stick around for just a minute, I have a couple more comments to make, super quick. But let's give everybody the full 5 minutes, please. Thank you. So just a little more than 10 seconds left. You want to be clicking on your answer right now to get it submitted. Remember, there's a multi-click process to get it submitted. And time should be up. Okay, so real quick, I want to point out on the Sakai site that when you look at tests and quizzes, oh gosh, come here. And let me view this as a student so you can, so this is what it'll look like for you. Notice there is this thing here called free experimental quiz. The purpose of that is to give you the opportunity to kind of, if you want to do dry runs of, like, I mean, do I press save? And what if I just press submit, but I don't hit save? Does that work too? And, whatever. If you want to make sure that you have the mechanics right. If you want to make sure that an app on your phone will work with this, that's the purpose of this free experimental quiz. You can take it as many times as you want. It does not count to your grade. It will show up in the grade book, but it does not count toward your course grade. The other thing I want to say, real quick comment, is today we did the quiz at the very end of class because I needed to introduce it and, talk about various this and that. But going forward, the quizzes will all be at the very start of class. It'll be the first 5 minutes of class. So make sure to come on time so you can have those full 5 minutes. See y'all later. See you Friday.